So here are the notes for section 4.8. You're going to solve quadratic equations using the quadratic formula. Now, anytime we are solving quadratic equations using the quadratic formula, we need to make sure that our equation is set equal to 0. Okay, so remember that our general quadratic equation is ax squared plus bx plus c, where a, b, and c are values. So the formula that we are going to be using for the quadratic formula is going to be x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So you definitely want to make sure you write that somewhere because you will be using that basically for this entire section. So make sure you have that down, okay? Okay, so let's go ahead and start some of our problems. The first one we have is we're going to solve x squared plus 3x equals 2. Now remember, as I said, every single time that we have a quadratic equation and we're using the quadratic formula, we need to make sure that we set the equation equal to 0, okay? So that's what we need to do here first. We need to set our equation equal to 0. Now, when we are setting our equation equal to 0, we really want to keep x squared positive, okay? So that means if it's already positive or whatever the variable squared is positive, then move everything else on the other side of the equation to it, okay? So notice here that our x squared is already positive. So that means I'm going to go ahead and move the 2 over to the other side, okay? So to move the 2 over, I need to subtract that from both sides. Now notice here that the 2 doesn't have any like terms. We cannot combine it with the 3x because the 2 does not have an x with it. And we can't combine it with the x squared because the 2 doesn't have it as well. So when I move it over, this is what we're going to get as our equation now. So I have x squared plus 3x minus 2. And when we are writing our quadratic equation, we want to write it in that standard form. So it should be always x squared, our bx, and then our c value. Remember, c is going to be what we call as the constant, so it's going to be the term without a variable. Now what I'm going to do is identify my a, b, and c values. That's going to make it easier when we actually have to use the formula. So my a value here is going to be basically the number in front of x squared. Now notice we don't see anything. When you don't see anything, that's when you can assume it's 1, okay? That's when you do it when it's multiplication. So anytime it's multiplication or division and there's no number in front of the variable, you can assume it's 1. Our b is going to be the 3, because remember it's bx. And then c is our term without a variable. The negative 2 is the one without a variable. Okay, now we go ahead and plug it into our formula. Now I'm going to go ahead and rewrite the formula. Remember, it's x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to plug in the numbers that I have for a, b, and c. Okay, so my opposite of b, so 3 is my b. Now I have to do the opposite. When I mean opposite, it's going to be the opposite sign. So 3 is positive, so the opposite sign would be negative. So I have negative 3 plus minus, and then square root. We have b squared. My b is 3. I'm going to put that in parentheses because we're going to plug this into our calculator. And in this case, because 3 is positive, it won't matter too much, but when that b value is negative, it's going to matter when you have those parentheses. Minus 4 then I multiply it by the a value, in this case it's just 1, and then I multiply it by the c value, which is -2. Yes, so you do need to make sure you bring down the negatives as well, so be careful with your signs. And then we divide that whole thing over 2 times the a value, as we said, which is 1. Okay. Now this is what we're going to be doing. So you definitely want to, and this is how it's going to be a little bit easier, we're going to plug what's underneath the radical, or another word is square root sign, into our calculator. So make sure you have your calculator out and you're doing this with me. Okay, so we're going to plug this whole thing, this parentheses 3 squared minus 4 times 1 times -2 into your calculator. Now we're going to do it without the radical, so make sure you're paying attention to what I'm putting into my calculator and you're doing the exact same thing. So parentheses 3 into your parentheses, we square it. Now I'm going to use the subtraction sign, minus 4, and then my parentheses 1, and then another parentheses for the negative. Now, be careful on this. Do not use the subtraction sign. Use the negative to represent a negative number. Because if you use subtraction there, then it might say error. Okay, so be careful or it could give you a wrong number. So notice I only plugged what's underneath the square root. I didn't use the square root at all here, just what's underneath it. I get 17. So now what I can do here is I have -3 plus minus square root, so the square root has to stay there. I haven't gotten rid of it. Now my number is 17 because I already calculated all of this all over, and now I'm going to go ahead and do 2 times 1. That's going to give me 2. Okay. Now our last thing before we can say box this as our answer is we have to simplify if it's possible. Now what we're going to do is we're going to look at the numbers that are not inside the radical. So the numbers that are not inside the radical are -3. We have the 2 in the denominator. Now there is another number. The number is behind the plus minus sign. Okay. This, as you can see, we don't see anything. What we can say is this is an assumed 1. Remember, anytime you don't see a number before a variable, a radical, or anything, and you're multiplying or dividing, you can assume it's 1. So we need to see if -3, 1, and 2, if they have any numbers other than 1 in common. If so, that means we can simplify a little bit more. Well, if we think about it, the only number that can go into -3, 1, and 2 is just 1. So because that's the only number that can go in all three, we cannot simplify this anymore, and this will be our final answer. Okay, so we have -3 plus or minus 1 square root of 17 over 2. Okay, let's go ahead and try our next problem. We have solved 25x squared minus 18x equals 12x minus 9. Now remember, always the first thing to do is to set the equation equal to 0. Notice that our equation is not set equal to 0, so we're going to go ahead and do that. Now, when we set our equation equal to 0, we always want to keep our variable squared positive. So notice 25x squared, that's already positive. So I'm going to go ahead and move my 12x over and my -9 over to the other side. So I'm going to subtract 12x from both sides. Now notice I can combine it with my -18x because they are like terms. They both have x. And then I'm going to add 9 to both sides. This one I cannot combine with anything. I cannot combine it with the x squared because it does not have an x squared. So does not have a like term. Okay, rewriting this, I have now 25x squared. Now I have to do -18x minus 12x. That gives me -30x. Then plus 9, and that's going to be set equal to 0. Now that it's set equal to 0, I'm going to identify my A, B, and C values. Okay, my a, remember that's going to be the number in front of the x squared. In this case, it's 25. My b is going to be the number in front of the x. It's going to be negative 30. You got to bring that sign along with it. And then my c, remember that's the constant. It's going to be the term without a variable. That's going to be my 9. So now I can use my quadratic formula to solve. So remember the quadratic formula, it's the opposite of b plus or minus square root of b squared minus 4ac, or 4 times a times c, all over 2a. So now let's go ahead and plug those numbers into there. So my opposite of b, so notice it's negative 30, so the opposite sign would be a positive. So a positive 30 plus minus square root. Now remember, with the b squared, we need to use parentheses. So I have parentheses negative 30 squared. And the reason we have to use parentheses is because if you don't, you're going to get the wrong number. So make sure you have parentheses. Minus 4 times our a value, which is 25, times our c value, which is 9. And this is going to be all over 2 times our a value. So that'd be 2 times 25. Now, just like we did in the last one, I'm going to plug what's underneath the radical or underneath the square root sign into the calculator, okay? So this is how we're going to do it. So I have parentheses. Now we need to use the negative sign. If you use subtraction, it will not work. It will give you an error. So negative 30 into your parentheses squared, okay? Minus, because we are subtracting this time, 4 times our a value, which is 25, into your parentheses, and then another parentheses, 9. Notice that I did not use the square root sign here, because I'm going to worry about that later. I just care about what's underneath in calculating that. I get 0. Now, here's the reason why we want to use parentheses around the negative 30 when we squared. If we didn't, let's say we just did negative 30 squared, we would get negative 900. But if we use parentheses around that negative 30 and then square it, that gives us positive. What this is saying when we don't use parentheses is the calculator is thinking you're doing 30 times 30 and then multiplying by a negative. When we use parentheses, the calculator is thinking you're doing negative 30 times negative 30, which now gives us a positive. So that's why parentheses are very important when we're squaring. Always use them. Okay, so the number underneath our radical or the square root sign is going to be 0. So now we have 30 plus or minus the square root of 0 all over, now we do 2 times 25, and you can plug that into your calculator. That'll give us 50. Now we need to simplify if possible, okay? And I didn't do this on the last one, which I should have. If you notice, we had a 17 underneath the square root. Well, we know we can't simplify that because that is not a perfect square, and there's no perfect square other than one that goes into it. So that's why we did not simplify the square root of 17. Well, let's think about this, square root of 0. Well, let's just plug that into your calculator to see what we get. So we do our square root, plug 0 in. That gives us 0. So let's go ahead and calculate that. So now I have 30 plus or minus 0 all over 50. Now let's think about this. If we do 30 plus 0, well, that gives us 30. If we do 30 minus 0, that gives us 30. So let's simplify this just a little bit more then. So that means I get 30 over 50. And let's see if we can simplify this fraction a little bit more. Well, we do know that 10 goes into both 30 and 50. So 10 goes into 30 3 times, or you can do 30 divided by 10. And then for 50, 50 divided by 10 gives us 5. So our final answer is 3/5. And I would recommend, especially for your homework tonight, leave your answers as fractions. Actually, in fact, when you use your calculator and you get a decimal, you're actually doing more work that needs to be. So just leave your answers as fractions, okay? It'll make it a lot easier. Okay, let's go ahead and do the next problem. So example 3. So we have solve x squared minus 6x plus 8 equals 0. Okay, remember, make sure your equation is set equal to 0. In this case, our equation is already set equal to 0, so we're good to go. Also notice that my x squared is positive, so we're good to go. We always want to make sure that our x squared is positive. If not, then we would have moved everything over to the other side. Okay, so because of that, we can automatically do our quadratic formula. So we are going to once again do our A, B, and C. And in fact, this is what I would like you to do. Pause the video and identify your A, B, and C values. Okay, let's go ahead and go over the A, B, and C. So remember, A is the number in front of the x squared. Notice we don't see a number. That means we can assume it's 1. Okay, for the B, that is the number right next to x. So in this case, it's -6. Don't forget that sign. We need -6. And C is our constant, the term without a variable. 8 is basically the term without a variable. Okay, so now our next thing is to plug these numbers into our quadratic formula. So remember, we got opposite of b plus minus square root. Now you might not have to write this all the time, the formula itself, and you might just automatically plug it in. That is all right. I just do this because, well, one, this is notes, and I rather do more work on the notes than less, so you guys have a better understanding. But also it helps you just to remember what it is, so you don't always have to look back at maybe your notes of, oh, what's the formula? Okay, so now what I want you to do is, once again, pause the video and plug in the A, B, and C values into the quadratic formula. Okay, let's go ahead and see what you got here. So in this case, our opposite of b is going to be the opposite of -6. So the opposite of that is positive. Remember, we just changed the signs. Then we have our square root. So we do b squared. So I have -6. Remember, don't forget your parentheses. I square it. Then minus 4 times the a value, which in this case is just 1. And then times our C value, which is 8. Okay, and then on the bottom, boop, got a little messy there. That's okay. Then we have 2 times our A value, which is going to be 1. Now, another thing which I haven't talked about is make sure, because I've seen this over the years, that students still put the 2 times A over this opposite of b plus or minus. Make sure the entire thing in the numerator is over the denominator, the whole thing. Don't just do half of it, okay? Now, what I would like you to do once again is go ahead, pause the video, and plug what's underneath the radical sign into your calculator. Okay, let's see what you got when you plug this into your calculator. Hopefully you use your parentheses correctly. So you have parentheses. We need to use the negative, not the minus, because it will not work. Now we use the subtraction, because we are subtracting 4, then our parentheses of 1, and then our parentheses of 8. And remember, I don't actually use the square root sign. I just plug in the numbers underneath it. I get 4. Okay. So now I have 6 plus or minus square root of 4 over 2. Now we need to see if we can simplify our square root. So the number 4, this is where you have to think, is for a perfect square. It is. If you don't remember your perfect squares, this is what I would suggest. You know, on the notes that you're writing, list out all the perfect squares from 1 to 250. Remember, we kind of already did this in the 4.5 notes. So if you wrote it out in your 4.5 notes, when we had to take the square root on both sides, get that out because we have that list, okay? So 4 is a perfect square. The square root of 4 is 2, so we have 6. And we already have the plus minus sign, so we are already indicating that there's 2, just like when we did taking the square root of both sides, we said we need the plus minus to indicate there's 2 solutions, which we have already done. So the square root of 4 is 2, and then over 2. Now notice that all of our numbers are integers. That means we can simplify a little bit more to get our answers. So that's what we're going to do here. So the first part is, notice that I can do 6 plus 2 and then divided by 2. So I'm going to write that here. My other one is when I'm actually going to do 6 minus 2 divided by 2. Okay, so when I do with the plus, 6 plus 2 gives me 8 divided by 2. And that gives us a nice number because you can do 8 divided by 2 in your calculator. That gives us 4. On the other hand, when I do 6 minus 2, that gives me 4. And that's over 2. So 4 divided by 2, that gives me 2. So just like with most of like our first example, we have 2 solutions, okay? Now, just like we've been solving with multiple different methods for quadratic equations, one was factoring. Remember, you either got 2 or you could have gotten 1 solution. Same thing with taking the square root on both sides. It was possible of getting 1 or 2 solutions. That's going to be the same thing here. Notice that we get 2 integers as our solutions. Since we get 2 integers, actually, in fact, this would indicate that x squared minus 6x plus 8, this quadratic equation is factorable. Anytime you get integers as your solutions when you use the quadratic formula, that also indicates that the quadratic equation is factorable. If we go back to our other equation, so when we got 25x squared minus 30x plus 9, we also got an integer as our solution. We only got 1, so that's okay, but that also means that this would have been factorable. The very first example, our x squared plus 3x minus 2, because we got a radical, that means this equation would have not been factorable. You would have to use the quadratic formula for this. Now, another thing is, some of you might be thinking, oh, this is just 1 solution. Well, in fact, it's actually 2 solutions because we have that plus minus. Remember from 4.5 that when you have the plus minus, that represents 2 solutions. So this really represents negative 3 plus 1 square root of 17 over 2. That's 1 solution. And the other one is when we have negative 3 minus 1 square root of 17 over 2. So this still has 2 solutions, okay? So you might get 2, you might get 1 solution. It just depends on the quadratic equation itself. Okay, let's go ahead. We're going to do one more example using the quadratic formula. And then after that, we are going to do some examples of how do we simplify if we do get radicals as our solutions. Okay, our last one, we have solved 2x squared plus 4x minus 5 equals 0. Okay, first thing we need to see if it's already set equal to 0. It is, so that's good. Next, we need to make sure our x squared is positive. Well, we have a positive 2x squared here, so we're good to go. So we don't need to move anything over. That means we can automatically do our A, B, and C. So what I would like you to do is pause the video and go ahead and fill out what would be your A, B, and C values. Okay, so A is going to be 2, B is going to be 4, and C is going to be negative 5. Okay, our next thing is to plug these numbers into our formula. So that will be the next thing you will have to do And remember our formula here. I'm just rewriting it so you remember. And it's just easier to, if you do write it out, where you need to plug everything in. So pause the video and plug in your A, B, and C into the quadratic formula. Okay, let's see if you got the same thing as I did. So our opposite of B, our 4 is positive, so the opposite sign would be negative. So I have negative 4 plus minus the square root. Remember, I got to use parentheses. I do B squared, so 4 squared minus 4 times our A value, which is 2, times our C value, which is negative 5. And then that's all going to be over 2 times our A. Okay, now I want you to pause the video again and plug what's underneath the radical sign into your calculator. Okay, let's go ahead and see if you got the same thing as I will. So we have parentheses 4 squared minus 4 parentheses our A value, which is 2, and then our C value. Don't forget the negative for the 5. So make sure you put it in correctly, because if you miss maybe or if you miss like a sign, like a negative sign, it will give you the wrong answer. So be careful. Okay, we get 56. So I have negative 4 plus minus square root of 56 all over 4. Okay. Now, before I move on, one thing I want you to note. Notice that for every single time that when we plugged in what was underneath the radical or underneath the square root, the number underneath was positive. Notice I have a positive 56. In our last example, I got a positive 4. On the second one, I got 0, which actually 0 is not negative nor positive, but 0 works because you can take the square root of it. And then on the very first example, we got 17, which that was positive. So make sure when you do your homework assignment, you get a positive number underneath the square root. If you don't, recheck your work, okay? You have to get a positive underneath the square root sign. Okay, just wanted to indicate that, so maybe it would help when you do your homework. Okay, so now, just like we did on the last one, we have to see if the number underneath the square root sign is a perfect square. Well, if you check your list, 56 is not a perfect square. But we can see if there is a perfect square that goes into 56. Okay, so I'm going to write 56 up here, because remember, this is what we did when we did in 4.5. When we take the square on both sides, we simplify. Okay, so let's think about 56. You have to figure out what is the largest, right, perfect square that goes into it. Well, if we think about it, or you can go down your list, okay, 4 would be our largest perfect square that goes into it. And 4 goes into 56. Let's see, if we do 56 divided by 4, it goes into it 14 times. So then I have square root of 14. Okay. So simplifying this, I would have negative 4 plus minus. Now, square root of 4, that's going to be 2. Remember, as I said, when we take the square root of a perfect square, you only do it once. Okay? Now, 14 is not a perfect square, and there's no perfect square other than one that goes into it. So that 14 stays underneath the square root sign. So I have 2 square root of 14. This should all look familiar because that's what we did in section 4.5 when we took the square root on both sides. Okay? Then we still have the 4 in the denominator. Okay. Now, once again, we have a radical, so we need to see if we can simplify even more. And what I mean is, are the numbers outside the radical, or any numbers that are not inside the radical, can they be simplified? Well, in order to figure out if they can be simplified, we need to see if there's a number that can go into all 3 of them. So is there a number that can go into 4, 2, and 4? Well, there is. The number that can go into all three of them is 2 itself, okay? So now we're going to go ahead and simplify here. So 2 can go into -4 2 times, and we need to keep that negative sign. Or another way of doing this is we're doing -4 divided by 2. Then we have the plus minus. Then we're going to divide this 2 by 2, so 2 divided by 2 gives us 1. Now, we cannot divide what's inside the radical. Think of that as like a variable. Like if you do a variable divided by a number, you can't do it, okay? So we keep the square root of 14 as is. That does not change. You got to leave it alone. Think about the radical as like a wall. Nothing can penetrate it. Nothing can come into it, okay? So that means the 2, we can't divide it. Now, our last thing is the 4 in the denominator. If we do 4 divided by 2, that gives us 2. So, make sure you simplify your answer all the way. You will need to do that in the homework, because if you don't simplify it all the way, you will not get it correct. So that means our final answer here is actually -2 plus minus 1 times square root of 14 all over 2. That is our final answer. Okay, what I'm going to do now is we're going to practice a little bit more with simplifying with these radicals, because that could be also the hard part, okay? A lot of this is pretty simple. Make sure kind of going back with the radicals, how to simplify it, how to take the square root of perfect squares, all that stuff. So here's our first example, and so I would write this on your piece of paper or on your notes somewhere, okay? So let's say for our first example here with simplifying, if we get the answer of 15 plus minus 3 times the square root of 2 all over 9. So let's just say we got this as an answer, okay? I just randomly came up with this. And I did that so that we can just practice our simplifying. So the square root of 2, we can't simplify that anymore. All we're really trying to work with is the numbers outside the radical. How can we simplify? So the first thing we need to figure out is 15, 3, and 9. Is there a number that can go into all three? A number other than 1? Well, there is. 3 can go into 15, 3, and 9. So let's go ahead and divide each of these numbers by that. So 15 divided by 3 gives us 5, plus minus. 3 divided by 3 gives us 1. The square root of 2 needs to stay exactly the same. Remember, any number underneath the square root has to stay exactly the same. Then I do 9 divided by 3. That gives me 3. So this would be my simplified answer. Okay, so this is what you would put in, or you would put as your answer, right, for any of the homework problems. Okay, let's try another one to simplify. Okay, now we have 9 plus minus 6 times square root of 5 all over 12. So once again, if we look at 5, 5 is not a perfect square. There's no perfect squares that go into it other than 1. So what's underneath the radical sign is all simplified. But we do need to see, is there a number that can go into 9, 6, and 12? Well, there is, okay? 3 can go into 9, 6, and 12. So let's divide all the numbers that are outside of the radical by that. So 9 divided by 3, well, we know gives us 3. We got plus minus. 6 divided by 3 gives us 2. And then square root of 5, so don't forget that. And then 12 divided by 3 will give us 4. And then this would be your final answer, simplified answer. Okay, let's try another one. And I probably will have you guys try this on your own. So let's say we have 4 plus or minus 6 square root of 3 all over 2. So what I want you guys to do is go ahead. So let's say this was, and I'm picking these numbers randomly, this was a final answer, and we need to simplify. Go ahead and try to simplify this, the 4 plus or minus 6 square root of 3 over 2. Okay, let's see if you got the same thing as I did. So remember, notice the 3 underneath the square root. That is not a perfect square, and the only perfect square that goes into it is a 1, so we can't simplify it anymore. But let's see if the numbers outside the radical, so the 4, 6, and 2, if they all have a number in common. They do. They all have a 2 in common. So I'm going to divide every number that is outside the radical by the 2. So I do 4 divided by 2, that gives me 2. Then I have the plus minus. And then 6 divided by 2 gives me 3. Then I have square root of 3. And when I do 2 divided by 2, that gives me 1. So, because my denominator is 1, to really write this answer correctly, my final answer in simplified form would be 2 plus minus 3 square root of 3. So this would be my final answer here. So if any times you get 1, like after you simplify, you get 1 in the denominator, go ahead and just put what's as the numerator as your answer, okay? Hopefully this is making a little bit more sense of how to simplify your answers when you get radicals. So we're going to go ahead and do one more. So our last example we're going to do is we're going to have 10 plus minus 5 square root of 6 all over 5. So just like in example 3, pause the video and simplify this answer. Okay, let's see if you got the same thing as I did. So 6 is not a perfect square, and the only perfect square that goes into it is a 1, so this is already simplified. But let's see if the numbers outside the radical, if they have anything in common. Well, if we look at 10, 5, and 5, the number that those 3 have in common is 5. So I'm going to go ahead and do 10 divided by 5. That gives me 2. I got plus minus. 5 divided by 5 gives me 1. And then I have square root of 6. And then 5 divided by 5 is also 1. So notice I got a 1 in my denominator. When that happens, I'm going to write my numerator as my final answer. So I have 2 plus minus 1 square root of 6. And I'm going to box it because that is going to be my final answer. Okay, make sure you do the homework for this section. And if you have any questions, make sure you contact me. Bye.